Okay, today we're going to be doing a lesson on solving systems by substitution. Yesterday we solved by graphing, and that can sometimes be challenging if you don't graph exactly correctly. So today we're going to do this solve systems by substitution, which is completely mathematically without graphing. Here's an example where you might see this in the real world. One cable television provider has a $60 setup fee and charges $80 per month. So we could write an equation for that. Y equals 80x plus 60, where x stands for the number of months and y stands for the total cost. For the second provider, they have a $160 equipment fee and charge $70 per month. So we could write an equation for that. Y equals $70 per month plus the initial equipment fee of $160. If the question asks, in how many months will the cost be the same, and what will the cost be, when we're solving for an ordered pair, the x and the y, which are part of that ordered pair, are the solutions, because remember x right here represented the cost per month, so that's going to be the number of months. And then the y is going to be the total cost. So when you find an ordered pair, you're actually finding some useful information. So on this next slide, I'm going to show how this works. Here's the two equations that we just wrote. We can solve this by substitution. To do that, you want to get a variable by itself. In both of these equations, the y is by itself. So you can substitute either one. I'm going to take the top one. Here it says that y is equal to that. So I'm going to substitute that in for y in the second equation, because that's what y equals. When I do that, it looks like this. 80x plus 60 equals 70x plus 160. All I did was substitute y for what y equals. Now we have a variable on both sides of the equation. It's easier if we try to keep the variable positive. So I'm going to choose to move the 170, or the 70, I'm sorry, from this side, from the right side to the left side. That way I'm going to have a positive 10x. Just to save time in the same step, since I'm getting x on the left side of the equation, I'm going to move the 60, I'm going to do that a different color. I'm going to move the 60 to the other side of the equation just to save steps here. So this cancels out. This cancels out. What is left on the left side of the equation is just 10x. And what is left on the right side of the equation is just 100. And of course, 100 divided by 10 is 10. So x represents 10. That, remember, x represented the number of months. So in 10 months, the cost for both cable companies will be the same. And what will that cost be? Well, we know that x is equal to 10, so now we're just going to take that 10 and we can plug it in to either one of the original equations. We can plug in 10 to this equation right here, or we can plug 10 into this equation. You're going to get the same solution, so you can just choose whichever one looks easier. If you like smaller numbers, you might choose the top one. So we would say y equals 80 times 10 plus 60, which of course y equals 800 plus 60. So after 10 months, you will have paid into the company $860. So that just shows you an example how I use systems of equations to figure out some information. If you're going through the PowerPoint, here it works through the same thing. Plugs it back in. 10 months at $860. Now just some practice of solving systems by substitution. You always want to have a variable by itself. And in this example, you have y by itself here and y by itself here. So you can decide which one do I want to substitute in. I think I'm going to use the top equation and substitute in here. So in the bottom equation, I know that y equals 2x. So I'm going to substitute 2x in for y. And then the other side of the equation obviously stays the same. So all I did was substitute this for this. Now I'm going to subtract x on both sides of the equation. Of course, that's an invisible 1, so we're left with 1x, or we just say x, is equal to 5. Remember, we're looking for an ordered pair. We know the x is 5. We can now plug that 5 into either one of the top equations to solve. You're going to get the same result. If we plug in 5 right here, 2 times 5 is 10. If you plug in 5 here, 5 plus 5 is 10. You get the same solution. So we know y is 10. So that if I were to graph these two lines, they would cross at 5, 10. I'll show you that right here on the PowerPoint. It's already done for you. I don't have to draw it. If I graph them, indeed, they cross at 5, 10. Okay, another example. This time, we only have a variable by itself in the second equation. Here's the y by itself. So we're going to substitute that in for y here. When we do that, we have 2x plus, now we're going to substitute x minus 4 into the y. Now we can combine our like terms. Now we have our simple two-step equation where we're going to add 4 to both sides. That results in 3x equals 9, and then of course x is equal to 3. So we know the first number of our ordered pair. We need to figure out the y, so we need to substitute the 3 back in. Again, we can do that in either equation. If we substitute 3 into x right here, that would be 6 plus y equals 5. And if we subtract 6 on both sides, y would be equal to negative 1. If we did it on the second equation, that would be 3 minus 4. And if you add the opposite, again, you get a negative 1. So our solution would be 3, negative 1. Erase this. And I'll show you that when we graph it, just to check it, indeed, they cross at 3, negative 1, which is the solution. Instead of going through the rest of this PowerPoint, what I think I'm going to do is pull up our assignment for the day and do a few examples on it. So here's our assignment for the day. Let's start with number 6. I'm just going to kind of randomly pick some here that have some different concepts in them. On number 6, you will see that we do not have a variable by itself. We're looking right here at number 6. But we do have a variable with a coefficient of 1. To make your life easier and to avoid fractions, which a lot of us like to do, we want to find the coefficient of 1. So this is one with the coefficient of 1. We want to get the y by itself. Well, to get the y by itself, we have to move this term to the other side by using inverse operations. So since the left side it's a negative 3x, we're going to add 3x over here. And this cancels out. So now we're left with y by itself. Y equals 7 plus 3x. Now we're going to substitute that in for y right here. Now if you notice, what we have right here is a binomial. It has two terms. And it's being multiplied by 2, which is a monomial. This is going to create the distributive property. So when we plug it in, we want to put it in parentheses. So in this equation, we have 5x plus 2. Now we're going to substitute what we know y to be in place of y. It is a binomial times a monomial, so we're going to put it in parentheses, plus 3x. I'll copy the rest of the problem equals 3. So the first thing we're going to do is the distributive property right here. So 5x plus 2 times 7, which is 14, and 2 times 3x, which is a positive 6x, equals 3. Now we can combine our like terms. That's 11x. I'm going to go ahead and move this 14 to the other side by subtracting 14 to both sides. And that also gives me an 11, negative 11. Of course, when we divide both sides by 11, x is going to equal negative 1. I'm going to have to erase this just because I don't have room. We now know that x is equal to negative 1. So I can plug it either into the first equation or the second equation, my choice. Let's just plug it in right here. A negative 3 times a negative 1 is a positive 3 plus y equals 7. If I subtract 3 on both sides, y is equal to 4. So over here on the side, hopefully, we will see the solution of negative 1, 4, right there with the word this. So there's our solution. I'm going to move down here to, I don't know, let's try number 10. On number 10, again, we don't have a variable by itself, but we do have 1 with a coefficient of 1 in front of it. So we're going to get this x by itself. So to get the x by itself, we have to move the negative 2y to the other side. So we're going to add 2y. That eliminates this. So we have x equals 2 plus 2y. Again, we have a binomial that we're multiplying right here times a monomial. So when we substitute it in, we want to put it in parentheses. Negative 5 times 2 plus 2y. Copy the rest of the problem. Plus 3y equals 11. Our next step is to do the distributive property. So negative 5 times 2 is negative 10. And negative 5 times a positive 2y is negative 10y. Plus 3y equals 11. Combine our like terms. That would be negative 7y. And if I add 10 on both sides, that would be a 21. And of course, 21 divided by a negative 7 is negative 3, and that was y. So we know our y is equal to a negative 3 in our order pair that we're trying to find. I'm going to get this out of the way because I ran out of room again. We're going to plug this back in to one of the equations. Now, when I move this to the other side, you can either use the original equation or you can use this one, whichever one you like. I'm going to plug it in right here with a negative 3. So that would be 2 minus 6, which is a negative 4. So our answer would be negative 4, negative 3. Trying to find if there would be another kind of tricky one on here. Let's just do one more. Let's do number 8, just because it involves a fraction. On number 8, we do not have a variable by itself, but we do have one with a coefficient of 1. So we're going to get the y by itself by moving this to the other side. So we're going to add 4x. So now we have y equals 4 plus 4x. When we substitute this binomial in right here, it's going to be multiplied times a monomial. So we're going to do the distributive property. So we have 2x plus 2 times the sum of 4 plus 4x. And that's equal to 13. Next, we're going to do the distributive property. So 2 times 4 is 8. And 2 times 4x is 8x. I'm going to combine my like terms. That would be 10x. And I'll move my 8 to the other side. And that would be 5. This time when I divide both sides by 10, I actually have a fraction. Because I had 5/10 when simplified is 1/2. So we know that x is equal to 1/2. So now if I substitute that back in, I'm just going to substitute it into this one. So a negative 4 over 1 times a 1/2 plus y equals 4, because these cross cancel, and I'm just left with negative 2 plus y equals 4. So when I add 2 to both sides, I'm going to get 6. So my solution is 1/2, 6. I hope that doing these examples for you has helped. Good luck with solving systems by substitution.